Cool. Yeah. And Christian, if just again out of gratitude for you hosting us, feel free to plug Synereo now if you want to, and then we'll probably jump right into it. Trent, I want to confirm with you just really quick about the distribution of this video and the permissions you'd like associated with the recording. I figure we hit the record button sooner than later here, or pretty much after you give us the go-ahead. I'm defaulting to CC attribution share alike 4.0 at the moment, but let me know if you had something else in mind, or yeah, I'm open to whatever you're comfortable with.
Yeah, no, that's fine. Sounds good. And feel free to plug Synereo too. I'm a big fan myself, so hi to the other guys there, Dora and Greg and stuff.
Cool. Yeah, Christian, you want to hit the record button?
Yeah, we're recording right now. So yeah.
Okay, sweet, perfect. Glad that worked out. All right, yeah, Christian, I'll let you go ahead, and then Trent, I'll be doing the rest of the interview, and it's pretty open. Feel free to interrupt whenever. Ask your own questions if you want to point the questions in another direction. I do have a general format that has worked pretty good for getting some intriguing, juicy stuff. So we'll see how that goes.
Sounds good.
Go ahead, Christian, if you want to intro now, or we can do it at the end.
Yeah, we can just do it at the end. If you
all right,
I'm just... Yeah.
Cool. Well, I'm just going to dive right in then. So, Trent McConaghy, thanks for joining us once again. If you would like to give your super brief, I've just met somebody, the typical 2-sentence intro you use, if you would.
Sure. So assuming this is a blockchain audience, basically I'm co-founder of BigchainDB, and Ascribe. BigchainDB is a scalable blockchain database, and Ascribe is a platform, plumbing basically for IP on the blockchain. And where we spend most of our effort is BigchainDB. It's a database that looks, acts, feels like a database, but happens to have blockchain characteristics.
Do you spend most of your time working in that general arena, the blockchain arena?
Yeah, we're full-time at it now. Yeah, I have been for a couple of years.
Very cool. Congratulations on that. And Big Chain Database and Aspire both looked really awesome. I first saw your work at the COALA Koala conference, or the blockchain workshop at New York University. I'm curious, how did you arrive to the work you're doing today? If you want to just tell a open-ended story of sorts, or whatever you want to share towards your journey into the blockchain space.
Sure. So, I've been programming since I was a young kid. I was a, technology sort of geek, all that. But also, grew up, my mother was an art teacher, so in the art world, and that'll have ramifications later in my story. And then, out of undergrad, university, I did electrical engineering, comp sci undergrad, and a lot of painting on the side, by the way. I started a company that was doing AI for designing computer chips, and that went well. And in fact, in the end, did 2 companies in a row. Sold the first one, and the second one was going well, going strong. Helping to drive Moore's law with machine learning, this sort of thing. And along the way too, I spent a lot of time in AI conferences, and they're actually, just like blockchain, you'll find people from all different sorts of fields there. It's not just about designing computer chips. It's whatever industry you want, whether it's financial or art or whatever. And one of the people that I got to know well was a guy who was doing crypto applications for DoD, the US DoD. And in 2010, he taught me about Bitcoin. He was raving and raving about it. I'm like, okay, I'll go check this out. So actually, I learned about Bitcoin pretty early on too. And when I was doing my AI work, going back to the late 90s, up to a couple years ago, full time, there's a lot of distributed system stuff too. So, a lot of doing things at scale, this sort of thing. And obviously, I'm a student of the web, all that, follow that, a user, etc. So when I heard about Bitcoin and learned about it, then I immediately kind of got the implications and how it would be exciting. And I bought some Bitcoin, not enough, woulda, coulda, shoulda, and just followed it more closely as time went on. And in 2013, I started thinking a lot more about the blockchain and what it meant, what it was, all of this. I was just curious. How does this thing actually work? And uh, at the same time, my wife and I had just moved to Berlin too. So we were starting to hang out. I was starting to hang out at Room 77, which is the very first bricks and mortar place in the world that accepted Bitcoin. And they accepted it for beer, which made me happy. So that was good. And, I moved to Berlin and met a bunch of people that were very enthusiastic about blockchains too. I'm from Vancouver, where I had a bunch of friends too who were also enthusiastic. And so in mid 2013, I go on and on. I get excited about AI and drones and all this. And my wife and I had just visited an art gallery. She's actually a pro art professional, a curator, a museologist, this sort of thing. And we were talking, actually, I was going on and on about blockchains, and then the conversation switched to art. And we had realized that there was this challenge in the world of digital art of how do you own digital art? How do you collect digital art? And, we still had the neurons firing from the blockchain side, and we kind of collectively arrived at the answer, well, could you own it the way you own blockchain? And that was a really great, own it the way you own Bitcoin. That was a really good question to ask, it turns out. So we pulled on the thread, and it actually worked out. You have to deal with copyright and all that, but as sort of a first cut at the answer, it was pretty good. So we started working on that project actually pretty quickly, just on the side. I had my full-time job on this company doing machine learning for designing computer chips. But, worked on it on the side and watched bit by bit the idea of blockchain and so on gather steam. Remember, this is 2013. It was barely a concept for most people back then, let alone sort of a movement. And by basically summer of 2014, we had made sufficient progress in the prototype, et cetera, sort of hacking away on weekends, et cetera, that myself and two others, Masha and Bruce, decided to basically jump in full time and really go for it. And so we did. And that's when we started Ascribe as a company for basically generally IP in the blockchain, but really zooming in on copyright and more particular as a target initial market, digital art.
Quick question. Oh, sorry. Just to go back just a little bit, as I'm still new to crypto Bitcoin space or blockchain space, crypto DoD you mentioned, is that acronym with distributed something?
No, that's United States Department of Defense. So he basically was, or is actually a consultant, that sells the services to the U.S. Department of Defense. And, they have a lot of super high quality people that work for them in various ways as consultants or full-time and so on. And, some of those people happen to be connected into the AI world too. And that's where I came across them. Right. So, and that's why I heard about it early on, despite not being a professional cryptographer myself or anything, as a professional AI person, right? Artificial intelligence.
Very neat. And if you wanted to go further, drawing the lines to the present, please do go ahead. Although I'm interested to bring you back a little bit further after that in just the path to becoming an electrical engineer and more about your growing up, whichever direction you want to take it still.
Sure. Well, I mean, let's just sort of complete this arc, and maybe we can circle back if you like. So basically, we dove in feet first into Ascribe full time by summer of 2014, and raised some money, hired some employees, etc., and launched in very early 2015. I think February of 2015. We launched Ascribe.io, which was basically a way for people to register their works, which means claiming copyright. And that timestamps the copyright claim onto the Bitcoin blockchain, and then also a way for them to transfer ownership of these works, which comes down to bequeathing a subset of rights from person A to person B. And the benefits of the blockchain, the main thing is that you actually get this perfect provenance, right? It's this ledger that no one owns or controls, and that perfect provenance basically cracks the problem of ownership of digital goods, in particular digital art and other items like that, where there's luxury goods, scarcity, that sort of thing. So that was Ascribe, and and it's still going strong. We launched it, we grew it, And as we are growing it, we offer Ascribe.io, a web app for end users targeting towards artists and institutions, but also the backend, the API, where third-party marketplaces could tie in and basically use it to register items into the blockchain, claiming copyright, etc. Get going in 15, 20 minutes, very, very quick. And as we were talking to various marketplaces, etc., one marketplace we were talking to, they had 20 million users, and going through 100,000 images a day. If we tied that, if we made that go into the Bitcoin blockchain, which we had integrated into, it would basically effectively double the number of transactions a day going through Bitcoin. And Bitcoin was already showing signs of strain in fall of 2014. So we actually had to say no to a bunch of potential customers simply because it could not operate at the scales we wanted. And but we said, okay, that's fine. We'll just focus on the interface. And we were nudging a bunch of friends to improve the scale as time went on. Then as we kept going, there was another issue that we identified, and that was a lot of people were very hesitant to put their work online at all. They said, okay, well, this is kind of cool. I like that I can timestamp and register. But what if people copy my work and put it out on the web and copy, 1,000 times, a million times? I feel like I've lost control. And they said, can you lock it up? Can you encrypt it? Can you watermark it, etc.? And that's kind of like, against the very thesis of what Ascribe was about, which was sort of, this cultural commons, where it's this balance between artists getting compensated and, cultural works for the world over the decades and the centuries to share. So if you DRM it up, it's basically a horrible UX for everybody. And so we said, instead of that, what if you actually had full visibility into everything you saw? Everything whatever you want, this image you uploaded or whatever, if you could see the spread of that image throughout the web. And they said, that could be cool. So what that means is it's sort of like a reverse image search like you would have with Google, but it's not just showing you the similar images, it's actually showing you all the different places that a particular image or similar images show up online over time. So we built that. We released it in late 2015. We called it Where on the Net, Where on the .net. And it actually, it doesn't have any blockchain stuff itself, per se. It's got a heavy dose of web crawl. We swallowed, I think, 200 plus terabytes of data and did machine learning based distance image search to basically identify similar images. So it was sort of a big data problem. And we swallowed 15 billion images. And we're like, well, this would be really cool if we could sort of register this onto the blockchain to know that, hey, we have we have cited these images at this point in time. But if we put that onto the Bitcoin blockchain, which we're using, once again, it would tie it up for a long, long time. In this case, back of the envelope calculation, it was looking like a century to tie it up, and we'd probably make a bunch of enemies too. So we had no interest in that. It would also cost a lot of money, right? These days, a transaction on Bitcoin is about 10 cents. So 15 billion images, it's not a good way to spend your VC financed money, right? And obviously, we didn't raise 1.5 billion. No VC would pay you that to do that. So anyway, that was a challenge, right? So we kept running into the scalability issues. There was the web crawl stuff, but even more importantly, just serving these marketplaces that were at scale. And we realized in general, if we wanted to do anything at scale, if we wanted to move from sort of this proof of concept-y thing on a blockchain to something where we could serve customers with 10 million, 50 million users, whatever, going through 100,000 plus images a day, et cetera, we just needed a different solution. So by mid 2014, late summer, we decided to actually conduct an experiment. Sorry, 2015. Late summer 2015, we decided to conduct an experiment saying, what if we were to scale up, achieve scale somehow? Everyone else had said, let's try to scale up the blockchain. We said, what scalable technologies out there already exist? This is sort of based on my experience in machine learning. I had actually had the experience where if you start with an existing algorithm and just try to scale it up, you'll maybe get 2x or 10x if you're lucky. But what you need to do is you need to keep the inputs and outputs the same, and you need to let go of your pet algorithm, and you need to basically design for scale from day one, right? So if you do this, I've done this again and again in the world of machine learning with various different problem applications, from symbolic regression to rare event estimation and so on. And I found this again and again and again. You have to design for scale from day one with an algorithm. You can't hang on to your precious algorithm. So when it came time, when we were thinking about, how do you achieve a blockchain at scale, blockchain technology, we asked, well, are there any other examples of storage storage technologies that are at scale? Maybe a scale enough to serve the planet, right? And you start looking around and you see that Visa and MasterCard have 2,000, 4,000, 5,000 transactions per second. You look at Twitter, it's 5,000 and peak of more than 100,000 transactions per second. Or you look at things like Netflix, it's actually serving at 1/3 of the bandwidth of inside the USA for the internet itself, right? Global email is more than 1 million transactions per second volume, which is kind of incredible too, right? So if you really want sort of a network at the planetary scale that people have been dreaming of with blockchain technologies, the good thing was there was actually a precedent, and it goes back to research that was initially thought about, in the 60s with the early days of the ARPANET, and then developed over the years with everything from, a lot of really great research out of SRI in the early 80s, Microsoft, et cetera, people like Leslie Lamport and so on, developing these theories of how to achieve consensus. How do you get different nodes in a network to agree on the same value? Research going back decades. And this is actually what modern applications like Netflix actually use, is they use basically these distributed databases using consensus algorithms that were developed going back, a lot of the developments from the 80s and 90s. So we said, okay, great. We looked at, for example, Netflix, they did some experiments on a database called Cassandra, which actually came out of Facebook. And they found that with, as they added nodes, the scale would go up. So it could actually handle 1 million transactions per second when it had, I think, about 350 nodes. That's pretty cool, right? As you add more nodes, throughput goes up. That's profound, right? That's actually not what you see with traditional Bitcoin network. As you add more nodes, it doesn't improve throughput at all. And in some ways, it actually improves performance. And the big challenge was basically it's because, traditional blockchains had a full copy of everything in every node. Whereas the trick is if you have many technologies, but one of the big ones is sharding. So each node only stores a fraction of the overall data. And then as more data comes in, only one or a few nodes actually have to spend the resources and bandwidth to actually swallow that data. And that's basically how you get throughput up, as well as capacity, right? So you have sharding, but you have backups of the data and backups of backups, and that's replication factor. So if you have 2 backups plus your main copy, that's a replication factor 3, et cetera, et cetera. So anyway, that's a bit of a background, but just going high level. So late summer of last year, so 2015, we said, okay, rather than trying to scale up blockchain technologies, rather than trying to sort of big datafy it, let's start with existing big data technologies, distributed databases, and blockchainify it. Stuff that already scales, and add in blockchain characteristics. So we basically did a quick experiment on this, adding in the characteristics of decentralized, as in no single entity owns or controls, assets, as in you can register assets, you can transfer assets, sort of assets can live on that storage medium, and the owner of the asset is the person who has the private key. And immutability, so basically a greater degree of tolerance to deletions, et cetera, than you would normally see in, say, a logging database, because it's always sort of shades of gray. It's not just sort of like zero immutability and then perfect immutability. It's always shades of gray. So we added in these 3 things, these blockchain characteristics on top of an existing distributed database, and it worked remarkably well, actually. We were kind of happily surprised by how well it worked out in those initial experiments in the fall of 2015. So from those results, we said, okay, great, let's double down and spend more resources. So we did, and basically to the point of where we could announce to the world that we had built this technology, the V0.1 of it, we announced in early February of this year, 2016. And since then, we continue to develop the technology, improving it. I think we just released version 0.4. And it's got the scale. We continue to optimize it that way, and we continue to add in greater and greater security to the point where it's secure enough that you can use it in pragmatic blockchain deployments. So right now, people are using it all over the world for proofs of concept, etc., knowing that it's at scale, and all the other benefits that you get from a traditional database. Things like acquire that you manipulate data. Are you going to use a blockchain explorer? That's kind of like a band-aid solution. It's much easier. Or are you going to write like 5 lines or 5,000 lines of custom code just to scan a list of stuff? It's much more straightforward if you have something like a SQL style language or modern variants for databases, things like Requel, the RethinkDB query language we build on RethinkDB, which is sort of like SQL meets JSON. So it's sort of a hierarchical keys, and it's a document store. So basically, you have, in general, when we built BigChainDB and released it, the overall idea is that it's bringing together the best of these two worlds of these big data distributed databases, which have really great performance, high throughput, low latency, high capacity, scale in general, queryability, permissioning. You bring that together with the characteristics of blockchains, the decentralized nature, the immutability, and so that's where we're at now. We're basically moving forward, continuing to refine towards 1.0 that can be considered production. We also are moving towards a public version of DB, so we'll be announcing more on that in coming weeks. Because people can right now people can deploy their own public want, but we see that it could be a nice sort of default network for a lot of people. And of course, in general, people can deploy for private versions too, all they want, however they want for different applications. So that's, I think, a good overall overview.
Yeah, that was great. I think I have 6 questions from that. Love the Bitcoin for beer little story at the end there, and excited to move forward with this conversation. I'm especially interested in what interested me originally is that idea of people being nervous or people having fear of losing control in the challenge of bringing people into this commons production mentality, into this culture, into this community of not just decentralization, but of accessibility and openness and sharing. I know the sharing word has gotten all mixed up these days with the big sort of netarchical capitalist platforms, as the P2P Foundation would put it, or just the plain rental economy that we see here on the ground. But if you don't mind, I'll turn it back to your background or growing up foundation a little bit, just to get a better sense of your language and your culture that you identify. Obviously, the blockchain space and distributed and crypto, all of these fields are accelerating quite a bit. I mean, technology in general is accelerating quite a bit, and lots of exciting stuff. And it seems like you've been doing really excellent work. So just glad to be here with you once again. If you wouldn't mind going back, where did you grow up?
I grew up at a farm in the middle of Saskatchewan, Canada. So Saskatchewan is like, take Kansas, which is the middle of USA, and go several thousand kilometers north. It's actually literally colder than Siberia there. It was a pig farm and grain farm. I would, wake up and go shoveling pig manure and then go play hockey. And, summer vacations were wake up at, you're out the door at 7, which is when the light comes, when the sun comes up, and you're out till the sun goes down, which is 10 p.m. So I grew up, working super hard, but at the same time, I was very fortunate. My parents got me a computer at a very young age. And, I didn't really have a very big allowance or anything. So me and one of my brothers, we just got into programming. So we didn't have money to buy video games, but I love video games. So we would just program our own. And so sort of did the sort of farm boy hockey thing at the same time as the computer thing growing up. And that made a big, big difference to, it's had a profound effect on my career since.
Farm boy hockey programmers. I love it. And so you're in a small town growing up in Saskatchewan, or a sizable town?
On a farm, like literally a farm with, a bunch of pigs and a bunch of grain, right? The closest town, actually, we call it a city in Saskatchewan if you have 6,000 people. So it was a city. 6,000 people is a city. And yeah, like elementary school, high school, all that, very straightforward. Actually, Canada has a very good education system, so I'm very happy with all of that. I had a very happy childhood, right? And two brothers who were also very driven and so on, and great parents. So that has all sort of been given me a really solid foundation for growing since as well, right? In undergrad and later on doing my PhD as well, and my different business ventures that I've done.
And were your parents, what did they do for a living? Are they also sort of the engineering mindset or that sort of, or where does the creative part come in? As you mentioned, your partner, your wife?
So my mother was a high school art teacher. So you can imagine, like someone who's an art teacher with three young boys, as they grow up, it's just a natural thing for her to want to teach a bunch of art. So all my career, I've actually balanced the art and the creativity side with the technical side. Even my first company and my PhD were about how do you reconcile, machine creativity with human creativity. So I spent a lot of time thinking about that.
That sounds like a whole.
Yeah.
That sounds super interesting.
Yeah, for sure. No, I find it super exciting, right? And the mainstream society and even mainstream technology discourse has only seen the tip of the iceberg for what's possible with machine creativity. So that's my mother's side. My father, he's the farmer. So between the mother, the teacher, and the art teacher, and the father, the farmer, when you're growing up in a farm, things break, right? So you fix them, and you just make it work, right? So it's very much a get it done, make it work mentality. And as you start working with more and more complex systems, you can't just sort of hack make it work. Sometimes it has to be much better, 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 right? And I was doing this with programming at the same time as with the farm, right? Sometimes like we had this actually box of broken devices and electronics in the machine shed in the farm, and I remember one day I took something out of the box. I thought it was in the box, and I took it and put it on the workbench, and like, I wonder what's broken with this. So I took it all apart, and then my father walks in, and he's like, "Trent, what are you doing? That's a $10,000 sensor. There's nothing wrong with it." I'm like, "Oh crap!" So I put it back together, and fortunately it worked. But in general, like playing with and fixing, electronics and mechanical devices, and building machine sheds and all this, all my whole life growing up, it kind of got me very used to just building systems, right? Building systems that work. And not, it's sort of like farmer logic, like in the sense of it doesn't have to be something that's perfectly, perfectly, perfectly theoretical that, everyone will love. It's something that works, right? And that's sort of been a lot of the essence of my career. And I found again and again and again, quite often, you can come up with solutions that at first glance, it's like, I can't believe that works. It's too simple. And it's actually fun when you arrive at a design like that. But you usually have to break past sort of constraints that you had that you didn't realize that you had, right? So, a great example that I found, I guess more than 10 years ago in my career now, spent a lot of time in this field called genetic programming. And one of the subproblems there was to automatically come up with a function that would describe, a mapping. And the idea with genetic programming was to evolve it, to simulate, to have, tens of thousands, hundreds of thousands of random functions, and then you sort of have survival of the fittest, and you refine them, you refine them, refine them. And maybe 100, a million or 100 million evaluations, 50 generations or 5,000 generations, you come up with some functions that adequately describe it. Now that sounds really cool, right? And it's really, really exciting. Well, it turns out that you can do this 1,000 times faster with 1,000 times more scale. If you actually transform the problem, you keep the problem definition the same, sorry, but you don't try to evolve this and get fancy there, but you actually use some state-of-the-art linear regression technology and combine with really rapid iteration of sort of basis function discovery. So I did a paper on this back in about 2009, 2008, somewhere in there. And, we've been using that in production in my previous company since right after the paper. So like, I'm used to orders of magnitude improvements. And in this case too, it was orders of magnitude improvements by, going for ultra simple, but leveraging some best in class technologies. And in many ways, Big Chain DB is quite like that, right? It's leveraging some best in class technologies. Consensus algorithms have been around for decades. Better ones all the time. There's whole fields around that. So leveraging not only the theory, but the off-the-shelf software, et cetera, and then taking advantage of that and building the things on top that help to bring in the benefits that you get from blockchains, decentralization, immutability, and assets.
Sounds like a very healthy sense of looking back a couple generations and looking forward a couple generations, which I very much appreciate. I'm curious, just one more question, and also to cross my T's and dot my I's. So growing up in like that, it all is a product of the harsh climate that you were living in there. Got to keep the basic systems running. If there's a mistake with the farm, like that's dangerous almost, or like could drastically affect the livelihood of your family.
Well, I mean, if you are outside in the middle of the winter in Canada, it's actually like some weeks it goes to 40 below. That's the same in Celsius and Fahrenheit. And so if you're outside for if you're outside without any clothing at all for 10 minutes, 20 minutes or an hour or whatever, you're dead, right? I probably frozen my ears like 10 times in my life, right? So basically what that means then is if your stuff doesn't work, if your heater doesn't work and all that, you're dead actually, right? So there's sort of always this sort of mantra of, making sure that things are work and having backups and backups of backups and all of that, right? So, reliability is a key component and just things working, right? Because if things fail, yeah, you're dead.
Yeah, that makes sense. And you, just a really quick secondary education onwards, you mentioned you had like pretty good primary education growing up in Canada, and I imagine that went to secondary, and you mentioned electrical engineering. Did you pursue a master's or go beyond that?
Yeah, so out of high school, I studied at University of Saskatchewan in Canada, which is just a couple hundred kilometers from where I grew up. And the reason I did that was because I had to help my parents farm. So every weekend, when everyone else is off partying, I'd drive back to the farm and spend the weekend driving grain trucks and gigantic combines and stuff, and studying in any spare time I had, so that I didn't get behind in university. So that's where I studied. I came out of it. It turns out that it was an excellent program, for engineering and for computer science. Canada has a much more balanced system. It's not sort of tier 1 and tier 2 in the extreme ways that you see in USA and elsewhere. So I came out of that. I did actually 2 degrees, computer science and electrical engineering, and you can combine it in 5 years. So that's what I did. And for summer work, I actually worked at the Canadian Department of Defense as well, and that's actually where I cut my teeth doing AI. I was doing AI for fun on the side, coding and stuff, but I actually got to do it professionally, and even published a paper on it as part of undergrad. So that was sort of the undergrad, and then straight out of undergrad, I started my first company, combining AI and electronics for the creativity side of things. And then after that company was acquired in 2004, I took some time off and hung out on the beach in California and that sort of thing for a while. But even when I was in California, I had already lined up to do a PhD in Belgium at a university where I was going to basically continue working on AI for creative circuit design. And the reason I chose Belgium is the main reason was for the group that I was joining. It was a combination of people who were doing the design, actual engineers, and the computer scientists who were building tools for the designers. And the group has had a reputation, over the last several decades as one of the top 2 or 3 groups, if not the top group in the world for exactly that. So it was a really great PhD program. I was there for about 4 years, and my supervisor was excellent. My colleagues were excellent. Had a really great experience out of that. And along the way too, I ended up starting the second company, which also was for AI and circuit design. That's Synereo, and that's continuing strong to this day. I did that. I sort of had 2 full-time jobs for a while during my PhD, and then after the PhD, I was there full-time for several years. And now, that company is being run full-time by my business partner. And we keep in touch, obviously, all that, but I'm focused full-time on BigChainDB and Scribe.
Awesome. So now to switch gears just a tad, but still towards the background, I'm curious, when did the internet become integral to your livelihood, and when did you really start participating a lot? Like you sounded like you started programming pretty early on, but I'm curious to pinpoint that a little bit more.
Yeah, well, basically, when in 1980, my parents bought me a TRS-80 for Christmas, me and my brothers. And it was actually 80. It was called the TRS-80 not because of the year 1980. It was actually released in 1978, but it's because it was running a Zilog Z80 chip. And interestingly enough, when you turn this thing on, it goes straight to a version of BASIC. So you can type in like print hello world and it prints hello world. So like the friction to get programming was super low, right? I mean, it's just right there. And I was pretty young, so my brother, I walked past the TV one day, and uh, I was looking at the TV and it was just flashing different colors. And my older brother Troy, 1 year older, I asked him, what are you doing? And he said, I'm programming. And I was hooked right then and there, and I've been ever since. So that was very early on with how I got into it. Basically, I think, was there more you wanted from that? Because I feel like
No, that I think gives a pretty good background. Actually, BASIC is where I cut my teeth when I first started programming. Although I've quickly gone more into what I like to call cultural programming when I'm being immodest, I guess. But this will lead us into the second part of the interview.
1 second. Yeah, I just realized I didn't fully answer your question. I apologize. You asked about sort of the internet, right? And this was 1980, so the World Wide Web didn't exist, and even TCP/IP was still in its infancy, right? So and where I lived, there were no BBSs or anything like that. So growing up, I was programming on a single machine, et cetera. My friends and I would share floppy disks of games or games I created even and stuff like that. And I think the very first time I used the internet was in about, let's see, 91, 92, somewhere in there. But when I started undergrad in 94, the very first thing we had to do was sign up and start using email. And that's been one of my primary tools ever since. And right on the heels of that too, the World Wide Web, all that. And then going to, so it became a key part of my tool set very, very quickly. And, in those early days, when I was working for national defense, for example, you couldn't go and like click and find papers online about AI. You'd actually have to go to libraries and ask for them. So I discovered that working for national defense, you could go to the secretaries, the admins, and you could give them a list of like 20 or 30 research papers that you wanted, and they'd actually have to go and source them from various libraries. And that was actually part of their job. So I would bring them lists of papers to read, and they would come back with stacks of papers for me. And that was sort of my like pseudo internet back in like 97, 98 for sort of research, just because a lot of this functionality we take for granted didn't exist back then. When I started my company in 1999, and actually the research we started in 1998, in final year of undergrad, sort of undergrad became a hobby and the company became the primary thing. We were actually doing distributed systems back then. Basically, to do any of this stuff at scale, you had to run a distributed, a network of machines, not just one machine, but 10 or 50 or 500. And it was basically evolving circuits, et cetera, right? So we built, distributed AI technology and built a cluster around it. Back then, they called them Beowulf clusters. Interesting aside, too, John Koza, one of the pioneers of genetic programming, he built a 1,000 node Beowulf cluster in the late 90s. And he was a professor at Stanford. Actually, the Google guys, when they were founding Google, they went and checked John's computer out. And that was one of the sparks of imagination for what has become today's modern data centers. It goes back to Beowulf clusters from the late 90s for genetic programming. So just kind of a fun tidbit. But sort of my background here, right? We were building AI-based distributed systems back then.
Yeah, thanks for flowing into that story and redirecting. That's really some interesting things. I'll definitely be listening back in on that one. And it also, I didn't want to miss the question. How much social time would you say you spend on the internet currently?
It depends. I mean, if you count email as a social network, then I spend a large portion of my day on the internet, right? Everyone has their different tools. I'm a big fan of downtime too, though, right? Like, not being connected. Into a book, sometimes a book on my phone, sometimes a book that's a good old, physical dead tree. Face-to-face conversation. I mean, I still see that the highest bandwidth way to communicate is face-to-face, right? But technology is catching up with a vengeance. So it's a balance. But I spend my day in front of a computer. A lot of that is communication based.
Right on. Yeah, it's so my broadly what I'm looking at, and just towards that a little bit. Some of these questions are a little bit towards getting some of your personality type, and just like, and I'm kind of curious. I might go around and send all of these previous interviews a Briggs Myers test if people want to opt into something like that, because I'm just curious how people's ideas about trust and sharing will change. Um, and I didn't ask very well before, but I guess we got somewhat of a sense. What were the kind of like I guess cultural norms or values around sharing and trust during your growing up period, as you would define in the community you grew up in, as you define it?
Right. Well, I spent a lot of time in the library. Actually, the local library had a total of 4 books on programming, and I think 3 of them were older than 1970. So, and none of them were very useful at all. So, like, we had to learn programming from the reference manual, basically. This command, here's a peek, here's a poke, here's go sub. Anyway, but that said, I did use the library a lot for a lot of other things. We would come back with stacks of books and stuff, and I saw that as a wonderful community resource. So, and in general, right, a small town or city of 6,000 people, everyone my age, I know, 1 year, minus 1 year, and neighbors around us, right? Our closest neighbor was 2 miles away. We know them, and we know all the neighbors within a 5-mile radius, right? So playing hockey, it's the same people, all this. So it's quite tight social networks that go back generations, right? My family, my grandparents on both sides had came to Canada between 1910 and 1940. So it was going back 2-3 generations, right? In the same area. And so there's sort of implicit trust. Some families build up reputation over time. It's not sort of like New York, which is 200 plus years sometimes, but it does make a difference, right? If you want to get a loan, if your family has a history of paying loans, for example, that makes a difference. But overall, it's very much a community, right? Like, for playing hockey or piano lessons or the library, all this sort of thing. It's everyone kind of bonding together, and you kind of have to. In Canada, or at least where I come from, but I think, and broadly speaking, actually, I don't want to ascribe a personality to a country, but Canadians have a reputation for being nice. Some friends and I were remarking the other day, it kind of rolls off the tongue to see a nice Canadian. And my view is there's a reason, right? I go back to Saskatchewan, where I come from, and all this, and I'm often just surprised by how nice people are, because in general, on average, the rest of the world, people are nice, but not as nice as there. So it's sort of a very strong community feeling, right? And I guess a related thing too that affected me growing up was this idea of co-ops. So in Saskatchewan, there's something called the Saskatchewan Wheat Pool, and it went back, almost 100 years. Farmers were trying to sell the grain individually, and they had a real tough time because that grain would be bought by, the ideal customers were hundreds of kilometers away or thousands. So instead, they pooled their resources together, had an organization to represent them, had delegates and all this, just sort of like a government. And those delegates would basically figure out deals for farmers en masse, right? And that was a big thing. So co-ops for selling grain, and not just wheat. This is actually the standard for barley, et cetera. And then the same thing for banks. There's something called credit unions that are very common in the area I come from. And as well as grocery stores. The main grocery store where I grew up was called the Co-op, right? And it still is. So a lot of the sort of shared cooperative culture goes back to my childhood.
Is that are there many people from the Scandinavian region? Is that kind of, I know that definitely in northern Wisconsin, I grew up in Wisconsin, and less so in my state than Minnesota, more so, which I traveled and camped there quite often. We'd pass through. So I got some of that co-op culture. I mean, definitely Madison, Wisconsin has a ton of co-op culture, and it's largely from Norwegian folks, Scandinavian folks. Is that true of your area as well?
Yeah, I mean, each town is sort of has a main demographic from some country. Back between say 1910 and 1940, land was almost given away for free. If you were willing to make that trek of hopping the Atlantic Ocean in some crappy boat, that you might die in, of scurvy or something, and then, you know, another several thousand kilometers to try to survive in these crazy harsh winters. I mean, you deserve a reward of more than that, right? And if you manage to survive, you know, especially those early days, people really had to work together, right? So they come from all over, right? There's, you know, one town is from, you know, a lot of people from Ukraine. The next town is a lot of people from France. The next town is a lot of people from Germany. The next town is a lot of people from Norway. And so it's really a lot of patches of different cultures. My mother's side all comes from Norway, so there's certainly that. My father's side is all Irish. So, but you know, where I grew up, actually, Melfort, the larger city, because it was really a larger city compared to, you know, the towns of say 500 or 1,000 people. That city actually had a mixture of more cultures, right? My mother, she came from a smaller town of about 200 people. That was all Norwegians, right?
I love that. Wow, that's really interesting. So I wanted your comment just before this one really made me want to add a question to my question, like to each interview about like, would you consider you grew up in a high trust environment? I mean, it sounds like you did.
Yep. Yeah, definitely.
Yeah, and so I've been exploring, looking at trust or breaking trust down into our understanding of the fairness in between people and the openness in between people. And I think you spoke very well to the fairness, but I'm curious about like the openness of. I mean, I grew up in a tiny town, 1,500 people in Wisconsin, and there's a Midwest niceness as well, or a Midwest politeness, but I would definitely not say my community was open in that way, or sharing in that way of their personal lives, of various things. Some things they were, and some things very much taboo. How is that for you up in your town?
I think in general, you know, it really comes down to the person, right? But I think the default.
I lost you for a second there. Maybe I still don't have you. Let's see. Oh, I hear you now. Trent, are you with us?
When they discovered the Pyramid of the Sun, that blew my mind because that's bigger than any of the Egyptian pyramids, and that's in South America.
Do you got Trent on the call still, Christian?
It's not the same, but it's the same phi ratio mathematics that exists in the plateau.
Yeah, that was my network. Sorry about that.
Oh, no worries.
My network broke my trust.
Yeah, breaks and trust. That's a whole another challenging topic, in my opinion, anyway.
Yeah.
But
I should add too. So in my career, maybe actually I kept encountering trust questions of trust again and again and again. Actually, you see it actually in AI, and you'd probably find this interesting because it's another dimension of trust. You know, even back in the late '90s, you know, looking at engineering ethics and all this, one of the questions then was simply, if I create a computer program that creates an automatic design or something, automatically designs, say, a car, right? And then the car crashes, whose responsibility is it? Is it the designer of the car? Is it the designer of the software? You know, the designer of the car that used the software? Or is it the designer of the software? Or who is it, right? And the same thing for computer chips, right? What if it's the computer chip inside the car that crashes? Then you know, is it come down to the software, et cetera, right? And if you think about it, there are, you know, legal precedents, and it usually comes down to who is the nearest human, you know, where's the nearest warm body, right? And you know, pragmatically speaking, if you say that it's the designer of the software itself, that's not the nearest warm body. But also, if it was that person, then it would be basically untenable as a business model, right? So this was actually, you know, a question that I encountered in the late '90s, just in my own, you know, looking at engineering and ethics. And then when I was doing automated design of circuits, the initial research we did, it would come up with circuits that you would look at and you'd say, I don't trust that. It looks like complete garbage because it doesn't look like anything that any sane human would design. And there was a reason, you know, the computer, it couldn't model all the constraints and sort of objectives that the humans had in their head. So it just, you know, we kept adding and adding constraints, and it was sort of like playing whack-a-mole. So it turns out that the solution to this was instead of having a super open and a design space, you actually constrain the design space to a set of building blocks that humans trust, right? And there's even analogies to this in the crypto space, right? You know, if you're a bank and you want to apply some, new blockchain technology, you're probably not going to be using exotic crypto. You're going to be using crypto that's been around for 20 or 30 years that everyone trusts, right? Just straight up digital signatures, straight up encryption, et cetera, et cetera. At some point, sure, they'll use zero knowledge proofs, but they want to just see that, other people tested in the field for 5 years or 25 years first, right? At least that's what I've seen. So there's this idea of, human trusted building blocks, and then a building block also has building blocks below it. So it's sort of the human trusted connections, which is just higher level building blocks, right? So that actually I've seen it occur again and again and again. And, AI, full open-ended AI kind of flies in the face of that. So you actually have had to make practical AI, you have to kind of constrain the systems. And then, another example is, my second company, we were doing basically efficient verification of circuits. So saying, okay, does this chip have a 1 in a million or 1 in a billion chance of failure versus 2 in a billion chance of failure, right? And doing that where instead of taking, say, 100 billion simulations, it only needs 10,000, right? And when it spits out its result and it says, okay, great, it's 1.1 in a billion, how do you know how to trust that result, right? And it turns out that you can actually develop technologies that help to make basically give insight and visualizations to make it easier to trust the result. The previous technologies that were out there, some of them were starting to be able to, efficiently do this, but none of them gave any insight to the humans that would make the technology trustworthy. And one of the breakthroughs that we had was actually developing visualizations coupled with the appropriate under the hood technology that it was much more trustworthy out of the box. So the question of sort of like, how do you, do you trust the technology? How do you trust it? All of this, it's not just the world of crypto. It actually crosses boundaries to other fields, comes up again and again and again in interesting ways.
Wow, yeah, that totally, brings me back to I have a mechanical engineering degree, just bachelor's, and that, yeah, a lot of the both probability statistics class and then, feedback mechanisms and just looking at the probability of error of the measuring tools.
Yeah.
And I think at the end of the day, what it makes me think about, one, that people being, visual is our like primary mode of communication. Like when somebody's lying, we know it first from their visual cues. Like we trust our visuals over any other sensory input, at least as far as I've seen the science. And it brings us back to people nervous about losing control. That fear of loss, of loss of control specifically. So diving into some of these ideas of like, how do we bring more people into or build the bridges and, build up the accessibility to get more people both able to like trust the technology and also, if they're able to trust the technology to develop it and to influence it being built. This is how our technology is going to be built best, right? The more people who are participants of building the system, leveraging that collective intelligence. And so I wonder, like, how does like in your mind, like I imagine you work fairly globally now, you've traveled the world some. How does like culture or like where somebody's from, their identity affect their trust? And then in that, how does trust infect someone's intention to participate in sharing behaviors, or really how does trust help with fear of loss of control?
So on the sort of first question and second question, in my view is, like, if you sort of look at personality profiles and stuff, what are the different factors that impact personalities? And country or region is actually a relatively small predictor. One of the things that I find most interesting is a person's personality changes more as they go from environment to environment than my personality to your personality, right? So that's actually kind of amazing, right? So the relative impact of a country's culture on a person's personality is actually relatively low. That said, there's still impacts, right? Like we were talking about with, on average, Canadians are a bit friendlier. But it really comes down to the individual person. So, when I'm, interacting with someone and, towards building a relationship of trust, I'm default trusting, right? For better or for worse. It burns me sometimes, but I'd rather have it burn me than kind of, be paranoid. It's my personal choice. Um, uh, so that's kind of, my view towards the first two questions. It really comes down to that, the individual and building a trust relationship.
That's interesting, though, that just really quick, sorry to interject, but I think maybe it was how I worded that question, but it's interesting that you put culture to country or culture to region. I don't know if that's necessarily an assumption I would make necessarily.
Yeah, sure. No worries. I could have used the word culture or country, and I agree they're not interchangeable. But the point is, the thing that has the biggest impact overall is kind of like where you are. Like, where I am right now, sitting in my office at work. It's a very different personality than me, hanging out with my kids, over supper time, right? And versus, hanging out at room 77, drinking beers, talking about blockchains, right? I'm still the same person, and there's threads of the same me, but overall, just like, and we all are, consistent individuals, or at least we strive to, or at least most of us. But it's just quite interesting that just the pure scientific evidence shows that there's, broad variance, right? So it's just about the variance from environment to environment, and I think that's really profound, right? So, and I also think that, like, I'm a big believer in the idea of equal opportunity for everybody. So I don't want to sort of pre-bias myself towards someone that comes from a particular region or a particular culture or whatever towards how they are, right? Inside Ascribe, we have people from all over the world, right? Men and women, and we're, it's because we're kind of like blind in a sense to where they're from. It's much more about who they are individually.
That's great. I mean, I'm a no borders person, I'll say, although I do favor membranes that we may traverse. Some lines in the sand do help here and there, of course. No, that's really awesome, and I think it's interesting to note the relationships between heritage, culture, and place is the word I would throw into this space that we've created verbally here. I still don't feel like I've done my research on the effective place. I do know, building the home builds you, and I do know that, right, the environmental justice sort of perspectives of, if you are forced to grow up around pollution or forced to grow up around certain behaviors, these are going to greatly affect you. Who your friends are, that oftentimes greatly dictates your own interests. I think, and my parents just taught me that, I don't know, I've always believed that, just based on my parents' experience of, like, surround yourselves with the right people, or it's going to greatly change your experience, and therefore your knowledge, and therefore your personal identity, how you see yourself, not just how others even see you. And so taking that forward, I guess, does place make sense to you? Because I think I want to take that word and see, like, what that, what I don't know. I'm looking for your subjective experience too, of course. In this.
Well, I mean, with this sort of thing, I'm an engineer, and I do like computational paradigms where appropriate. Obviously, metaphors always end somewhere. So, and also obviously I spent a lot of time in AI and machine learning and kind of related fields. I view, a pretty useful model for a lot of this is that, there's this dynamical system that is, Trent, and it's a combination of not just my brain, but my nervous system spread out, interacting with the rest of my body and my environment. But, it's got inputs, and then the state gets updated based on the inputs. And I can actually choose what those inputs are, right? So if I read a book about, I don't know, speed reading, then I'll be able to, like, read faster, for better or for worse, based on how speed reading is. Or I can read a book about, BFT algorithms, and that'll improve me that way. Or I can hang out with certain friends who have certain biases. Maybe they like surfing, so I I end up spending a lot more time doing surfing, and whatever biases that brings. And sometimes those effects, we don't even mean for it to happen, but it happens just by being in that environment, right? So placing yourself in an environment can have a bigger effect on you simply because you're exposed to a lot more stimuli that can, be positive or negative or whatever, right? So for sure, like if you want to have, if you want to grow personally, then it's useful to expose yourself to stimuli to grow, as well as to make sure that your internal dynamical system update, if you will, is framed in a healthy way to grow, right?
Mm-hmm. And so yeah, that totally makes sense. I guess just let's bounce to the second question quick, because I'm gonna kind of bounce between these two. You did that pre-survey, and actually, I guess I'll take just a brief second, if you don't mind, to just kind of list those for the future listeners of this, being values, autonomy and self-determination, heritage, culture, identity, trust, morality, altruism, ethics, and I like that you in the fill in the blank future was a great one. So that were just some words that you either resonated with or found effective or significant, I think was the wording of the pre-survey question. But to go back to that trust piece, like how, in your experience, how does trust affect someone's intention to participate in, contributing? Let's think about your end users, the artists that might be using Aspire, because I'm sure you thought about them quite a bit. How does trust affect that situation, and then how does place affect that trust?
I mean, overall, you can ask yourself, what are the factors that make someone decide to use a tool, whether it's Ascribe.io or BigChainDB or otherwise, right? And one of the factors is trust. Do I trust that the software will perform reliably? Do I trust that it will do what it says it does? A related thing too is, do I like the organization behind this? Because that matters to a lot of people, right? If if that organization behind is a value system that is, way out of line with the user's value system, then that's going to be a big negative. The user still might use it, but grudgingly, right? So, but there's other factors as well, right? Like overall, like, does it meet the performance specs that I'm expecting? In the case of BigChainDB, is it as secure as I want, as I need, et cetera, et cetera? Or in the case of Ascribe, right? Is it easy to use? Do I understand what's going on? A related thing for trust, like one of the things that there's a lot of proxies for trust, right? I'm sure you've thought about this a lot. What are the things that help trust? Openness can help, of course. If you think about traditional banks and governments, part of the reason that they're trusted, at least to whatever degree, is age and size, right? Or like let's say they're using Apple to buy songs on iTunes. Maybe it's not as old, but it's big, and you're pretty sure it's going to be around for probably at least another 5 years and probably a little longer. So when you buy a song on iTunes, maybe they've got a centralized database of who owns what, but you're okay with it just because they have sufficient trust. Whereas if you buy, some songs from some dinky little 2-person startup and they're storing their stuff, who owns and what on some, centralized database, are you going to trust that, right? So those are some factors for trust traditionally as well. And the cool thing is, that actually creates an uneven playing field for the incumbents, especially the big incumbents, versus the new guys, right? But decentralization technology helps to level the playing field, simply because you don't need to rely on age and size as a proxy for trust. You can actually just say, okay, the stuff that really, really matters, that I really need to trust, it's on this database that is out there that even the startup can't control, right? So Ascribe, relatively small startup, but the core database of who owns what, et cetera, we don't control. We don't store the passwords. If someone hacked Ascribe, nothing would happen, right? Everyone would still retain what they own. And so that's very powerful. And that's what decentralization technologies can really help, sort of to bypass these traditional trust obstacles and level the playing field for new guys.
Yeah, it's pretty cool. I mean, I was thinking just now, Aspire in many ways is just about kind of revealing the truth, or revealing the path. I mean, one thing, I'm working with some of the Inspiral folks out of New Zealand, and the indigenous culture there in New Zealand called the Maori people. They have some very intricate traditions around building trust and entering spaces, and it's very much based in my name is John, son of Sam, son of this person, and I live on this mountain by this river. And you mentioned like, right, the actual region or the country is less important, but the path that someone takes through life and the interactions they've had and where they are most of the time and what kinds of interactions, those are all things we want to know about. And when you talk about like, the maturity or the sustainability, or like, do I know the identity of this company or the values that it holds? These are all stories that we kind of get, or like we sort of draw this path of like, okay, I see their trajectory, I see where they came from, I'm guessing where they're going, and that either fits in with my paradigm or it clashes with my paradigm, and I will, choose to interact or try to protect myself from having to interact in some way. So I think that's I'm really excited about your projects in the sense that I feel like they're enablers of building trust. I mean, trustless is thrown around a bit here, or pushing the trust towards the edges. I mean, I think that's a really a beautiful way to describe it, of looking at what the internet can do, what our distributed future internet can do, perhaps. But here's maybe to push into it a little bit, like, and I think you mentioned a little bit some of the challenges. I think this was particular to Ascribe. So you were talking about how the whereinthenet.net identifies all the places a piece of media has been. Machine learning, it's identifying this piece of media. It's like, this is the same piece of media because of XYZ. And then submitting some sort of ticket representing like, oh, we've identified, this is the provenance that we've identified to this immutable blockchain that nobody owns, nobody controls to a degree. We control it to a degree, but nobody is we. I mean, there's the separation between individuals, and as you mentioned, that also is like a challenge to trust, the nearest warm body problem. So I'm curious, I just in general, I guess your thoughts on, and I hope I'm kind of framing this correctly. Please correct me if I'm wrong. But I guess what I worry about with some of these things is like how, right, when you get in a conflict with a person and there's like expectations about the agreement, or maybe there's even a law at play, which is another type of longer standing agreement that, maybe I didn't have a part in, but, by being a US citizen, I'm obliged to, like, there's a sense of like, oh, we can go in, or someone's accountable to that law. Maybe the politicians who made it, maybe the politicians who are currently in office. Like, somebody is accountable, and we recognize that like our laws aren't going to be perfect, or like we're going to have conflict around agreements, and especially when we look at common pool resources, we're talking like ownership issues, we're talking about who has access to use it, we're talking about the identity of the resource too, who has the ability to define that identity. And so I wonder, as we like move into trusting the agentive tech, as I've heard it described, I think that's Chris Noacel or somebody, just thinking in terms of artificial intelligence and like these algorithms that are agents of us, proxies of us to some degree. How do we provide that breathing room and that accountability for people to go in and say like, oh, this algorithm wasn't correct, it's producing these ill effects, somebody needs to be accountable to like change, and I heard even in coding, like, different programmers will be like accountable to certain specs. What does that look like in decentralized or distributed decentralized space?
Well, I think at the end of the day, we are all people. We all have identities that we have built based on our actions, reputations, that act as a major factor on how much people trust us. And technology that surrounds can be used to help catalyze the communication of that. And in some cases, it's sort of an effector on it. So in the case of, with blockchain technologies, I can make a claim onto a blockchain that I own a particular piece of digital art, right? I could be lying, but now that claim is actually being written onto this, global distributed ledger that no one owns or controls, that can't get deleted. So, I'm committing fraud in a very provable fashion, right? So that's it's a catalyst in this case for just, basically formalizing, claims that people make. And, there's plenty of examples, but overall, blockchain technologies, simply, change the shape of the dynamics of, they add new sort of features to how people can relate trust with technology, right? And then, other technologies too, like, statistics actually has a lot to say on this. You might be able, for example, you can fit a model, you have 10 data points and you can fit a model, and maybe it's just a one-dimensional model, so you can see the fit, of a linear line against the model. But what if it's actually 10 dimensions? How do you visualize that, right? Because, visualization can really help, but this is where other technologies come in, things like confidence intervals, right? So you can see that it has very, very little confidence on this prediction here. It's, maybe a value of 10.3 plus or minus 5.0, right? So it's like, hey, that's really cool. And of course, even the confidence intervals themselves can be untrustworthy. So you want to make sure that they don't make very many assumptions, and that goes down to the realm of like, non-parametric statistics, et cetera. So there's a lot of things, if you deploy technologies that make certain assumptions, you have to be clear about communicating those assumptions. If you deploy technologies that make fewer assumptions, they tend to be less scalable. And there's always sort of the engineer's challenge to reconcile, the degree of scalability with the degree of the ability to communicate lack of confidence, et cetera, right? So basically confidence intervals and statistics are sort of another tool that is strongly related to trust. Visualization is another one, right? All of them, help to augment trust or reduce trust, and blockchains too. So, but once again, overall, it comes down to us as humans, and it's just technology that is mediating this.
Totally. And so then how does oh, I am off mute, sorry. So then how, like, in your work particularly, I mean, like, right, you thought about some of the ethics of these things, obviously, and you identified like morality, altruism. These are words you either use or think about. How do you make sure your technology doesn't amplify like the negative paradigms that we have socially with each other around trust, around like ownership, and things like that?
Basically, you do your best, but you also try to be educated about this. Some people subscribe to the idea of, oh, I'm just supplying this technology, people can do what they want with it. But technology does bias towards certain behaviors here and there, right? And so good defaults matter. So if you actually put in defaults that nudge people towards behavior that is healthier, especially for society in the longer term, that's good. Now, of course, that's based on a value judgment that you yourself make, but that's fine, right? And ideally, you communicate those value judgments so that people using your technology understand that you're kind of building towards those values. And with Ascribe and BigChainDB, we're pretty upfront about our values, right? We try to be as transparent as we can. And there's, this goes back for forever, right? The idea of a double-edged sword. My favorite example is, Alfred Nobel himself. He invented dynamite. And he was super concerned about the negative consequences of this technology, right? Blowing up people and stuff that, hurt society. But of course, it had many positive benefits. Things like, building trains through the middle of mountains and, construction in other applications too. Building dams, all of this, which leads to, a lot of societal enrichment. He was acutely aware of the positive and negative effects, to the point of donating the vast majority of his fortune towards what has become the Nobel Prizes to raise awareness of this very issue, right? So I think we can't blithely ignore it. We have to be thinking about it all the time when we're building, and understand what the possible impacts could be. no one's perfect. Maybe we'll miss it. Maybe we underestimate or overestimate certain impacts, but we should try.
Definitely. Yeah, no, I think that's beautiful. I mean, technology is going to move forward with or without us. Well, I mean, I technically wouldn't move without us, but I guess there's certain cultural norms that are building in that direction, and seems like typically in favor of technology, since agriculture and writing and the like. Um, that's the argument of whether those technologies bring us in the good way is a whole nother can of worms. But let's see. I guess I'll just
I can give
kind
you
of
an
bring it.
example, actually. You know, if we didn't have GMO, billions would be starving, right?
Oh, I mean, yeah, totally. I mean, I have yeah, like I said, I mean, like, right, the things we use, the patterns that we inform our minds with through the technologies we use, the processes that we do. I mean, I think these are all very much reprogramming our brains in various ways. And in that analysis of technology, you know, some technologies we happen upon by just like that is, you know, that's where you get to like collective and individual autonomy, and also like our will and our intention, and gets dense, I would say. But to kind of wrap up this conversation, perhaps I guess I'll just bring you around to how does morality or altruism or ethics, in your understanding of them, affect someone's intention to share or participate in sharing?
They're intricately intertwined. I mean, you know, if you don't care about morality or ethics, then you probably, you know, there's a correlation with not sharing, right? So, yeah, it's intertwined.
Mm-hmm. And then, how does your technology account for that?
Well, in general, there's different calls that we make on degree of openness and balancing, you know, openness versus privacy. And, you know, we care deeply about both, but it's actually a tension, right? So how do you balance that? We think about it all the time. And, you know, we go out of our way to make our software open source, all this sort of thing. It's just, you know, day-to-day decisions that we make, but with this overall balance of like, you know, what do we want society to look like in 5 years, in 10 years, in 25 years, right? What do we want the internet to be shaped like? And at the very core, it is about leveling the playing field for opportunity, right? And then who will seize the opportunities? You know, so there are still going to be people who do better than others, whether it be a luck, but at least trying to, you know, make the opportunities more equal. So, for example, even with a scribe, right, it's just as easy for some kid in rural Canada or rural India to register a piece of work as it is for, you know, the wealthiest millionaire's kid in New York City, right? That's on purpose, right? We've made a point of making a Scribe.io free, the web app, and you know, a Scribe makes its money by charging a small fee to the large volume API users, right? So I guess that's the answer.
That's very cool. I feel like if others who are developing technologies in the blockchain space, and others are being as intentional as you, and looking as far back and as far forward as you, that we should be in quite a better place in a very quick amount of time. I really appreciate your very considerate answers, and all the sharing that you've done today, as well as very appreciative for your work, and I hope to continue getting to know that better. Any closing comments from you? I'm going to stay on the line for a brief second afterwards, and we can wrap up, but to maybe wrap up the distributable version.
Yeah, well, one thing that I can see, right, maybe we didn't touch on it, but sort of the macro level view of how sort of long-term society relates to blockchain and decentralization technologies. You know, you can view Internet 1.0 as sort of, or World of Web 1.0 of the 90s. It was very democratic. You know, a lot of people were very excited about many things happening. You know, the UX is not so good, right? But it was very exciting times. You know, the world was our oyster. You know, version 2, which was, you know, the 2000s, it was cloud, it was social media largely, right? And mobile sort of on the heels of that. But there was a large balkanization that happened where a lot of companies got a lot larger, and they basically have sort of like locked up their data sets. And it's kind of too bad. We have these giant information silos, and opportunities are kind of getting pushed away. But what's exciting is decentralization technology provides an opportunity to bring back some of the ideals of the version 1, and reconcile that with the cloud, with social media, with mobile, all of these things at scale, right? And hopefully it happens, right? The technology is coming along. Will society go for it? Will it be enough of a delta? That's one question I have. But I'm doing my best, and many of my friends and colleagues in the space were working very hard to really try to make this internet, not just the web, but the broader internet, have this foundation that we can be proud of, having been a part of, but helping to shape society, right? Internet obviously has had a profound effect on society, and we're sort of at a crossroads right now. We have an opportunity to partly rewire it, maybe heavily rewire it, in a way that, taking advantage of all these technology developments of the last 10, 20, 30 years to open up the playing field that much more, right? Equalize the opportunities. So that's what gets me up every morning, working on BigChainDB, working on Ascribe. These are fundamental challenges, right? Ascribe, it really is about, getting creators compensated, and balancing that with the shared cultural commons. BigChainDB, we see that it can end up being a critical piece of storage infrastructure towards the web. We really hope so. And working together with other complementary pieces, right? The awesome work that is being done by Synereo, the stuff from Ethereum, the stuff from IPFS, all of this, it's all complementary. And there's a lot of other awesome organizations out there too. And, we talk, and we're really trying to build this thing together. I think that's very exciting.
Well, I am very excited as well, and thank you for bringing in that beautiful vision, relieving some of that tension, and the call to action. And if you would, for our listeners, if you would like for people to be able to reach you, would you care to share a good contact point?
Sure. So I guess my Twitter is TrentMC0, so TRENTMC0. I tweet a fair bit. Also, if people want to email me, reach out directly, they can. So it's Trent at bigchaindb.com, or gtrent at gmail, or just Google me. You'll find many contacts. Yeah, those are the two main ways. Or, if you're ever in Berlin, reach out. Let's have a lunch. Let's have a beer at room 77.
Well, that sounds wonderful. I'd like to go spend some Bitcoin in Berlin and share a beer with you sometime, Trent. And this is the Distro Research podcast. You can find me at Co-op Change on Twitter. And thanks so much, Trent, again.
My pleasure. Thank you.
And thanks to Synereo for hosting today, and Christian Pearson for handling our tech.
It was a pleasure listening to you, Trent. I'm actually in The Hague, Netherlands, so we might be going to Berlin at some point this summer. So if you're working there all summer, if you live there, maybe I'll reach out to you.
Definitely. Awesome. Sounds great. For sure.
Great. Right
Cool.
on.
I look forward to following up. I got a couple of more technical questions, Trent, if you're interested around what you've looked into at all, the federated ID space. I'm trying to get a little bit more of a grasp on, and then also some of the semantic web. Both just in general, there's some attempts at like economic mapping and the I don't know if you're familiar with value flows. It's valueflow.ws, FLO.ws. Bob Haugen and Lynn Foster and some of those folks who have helped Sensorica develop their network resource planning model. The bit you were talking a bit on assets and ownership made me think a lot of the really how they're trying to pare down economic terms so that it can be easily mapped into anybody's tech. And thought you might be interested. They use a resource event agent model that was developed in Michigan in the 70s by I think it's Peter McCarthy. So they've kind of been continuing to jam on that and try to bring that into Web 3.0 as well, into our beautiful interconnected protocol vision here. But yeah, I'll toss you some of that stuff and maybe a couple links of some things you reminded me of. This was really great. Thank you so much.
My pleasure. Thank you. All right.
All right. Take care, you too.
Bye.